everyone, I want to give you a video on how to solve linear equations. Now, this can vary from really easy to kind of messy and hard. So let's do a little bit of both. So let me start at the really easy end. So to solve linear equations, so firstly, linear equation. So linear means first power only of the variable. So whatever your variable is, it can't be raised to any powers. Can't do anything else weird to it too, like take a square root or anything like that. So basically just the variable, no powers, but you can have coefficients. So the first thing to know about solving linear equations is the first thing to know about solving any kind of equation, which is the basic idea is you want to get the variable equals some number. So I'm guessing everyone probably already knows how to solve this equation, but I want to make a couple points. So I've got x with some other stuff around it and on one side of the equation. And so the basic strategy for this and every other equation that we're going to solve is to sort of peel off all the stuff that's not the variable we're trying to find, right? So I want to take away, I want to remove one thing from around the variable every time on every step. That's essentially what I'm going to do. So I'm thinking of this like that x is sort of, it's buried inside something. And I have to take off the outer layers to get to the x. So we're going to use properties of equality. As long as you do the same thing to both sides, you can do anything you want to an equation. So in this case, the thing I want to do is to get rid of this plus 5. So I want to use a minus 5, right? So I'm going to use what's called the inverse function. So the opposite of plus is minus, just like the opposite of divide is times. And so you can use them to cancel each other out, right? So since I have a plus 5 that's splitting up my x, I'm going to subtract 5 from both sides. Minus 5, minus 5. Plus 5 minus 5 is 0, and so that leaves me x equals, well, 7 minus 5 is 2. And that's in general what your answer should look like if you're solving an equation. It should look like variable equals a number, or possibly more than one number, depending on your equation. And that's basically it. So the general strategy, like I said, is to peel off all of the things that are messing up your variable, right? You want it to just be x. Over here, I don't have just x, I have x plus 5, so I got to get rid of the plus 5. And the order you want to do that in is the opposite of the order of operations. I presume you guys remember this, PEMDAS. Right? Parentheses, exponents, multiplication and division, which actually go together, and addition and subtraction, which go together. And you go left to right, right? In general, if you are trying to evaluate an expression, right? Like if I had, let's see here, 2 plus 3 to the second power times 4 minus 7, right? So what I would do here is I would try to evaluate all the stuff inside the parentheses first. Well, I can't, I have to simplify. So inside the parentheses, I'm going to have an addition and an exponent. So if I have addition or exponent to do first, well, the exponent comes first. So I do the exponent first, right? So I end up with 4 times 2 plus 9 minus 7. And then I look inside the parentheses and I say, okay, well, I only have one operation in there, so I'll do that one. So I have 4 times 11 minus 7. And now should I do the times first or the minus? Well, I should do times first because it's multiplication comes before subtraction. So 44 minus 7, which is 37, right? So when you are simplifying, which is what I'm doing here, I'm not trying to peel stuff off. I'm trying to cram it all together, right? So the idea here is that I'm taking something that I'm not like trying to get rid of this minus 7 or trying to get rid of the 4. I'm trying to take this stuff and just shove it all into one number. And so we do this. Simplifying, we go that way. Solving is completely the opposite. Solving is the opposite of simplifying. When I'm trying to solve for x, what I'm trying to do is not smash everything around the x. I'm trying to do the opposite of that. I'm trying to peel off the things that are around the x and take them away so that I'm left with just the x. So when you are solving an equation, you actually go this way. SADMEP. In general, you want to get rid of the addition and subtraction first, and then the multiplication and division, and then any exponents, and then any parentheses. So, let's see an example of that. I'm just going to do multiplication, addition, and subtraction here. I'm not going to worry about the parentheses and exponents yet, although we will get to them eventually. Maybe not in this video, maybe in a future video. So let's say I have 1/2 x minus 3 equals 11. All right, well, here what I've got is I have multiplication and subtraction both messing up my x, so I need to get rid of them. And again, I want to get rid of them not in PEMDAS order. Right, I'm not going PEMDAS, I'm going SADMEP. I'm going this direction. So I want to get rid of the subtraction first before I get rid of the multiplication. So the way I get rid of the subtraction, the minus 3, of course, is plus 3. Right, the opposite of minus 3 is plus 3. And so I have 1/2 x equals 14. Well, if half of x is 14, then you can probably figure out what x is. But let's keep thinking of this as doing opposite operations here. So multiplying by 1/2, the easiest way to think of getting rid of multiplying by 1/2 in terms of operations is probably dividing by 1/2. But I would argue that the easier way to think of this is that multiplying by 2 is the opposite of multiplying by 1/2, right? Flip it over and multiply, which is exactly what you do with division by fractions, division of fractions, of course. You could think of this as dividing by 1/2, and dividing by 1/2 means flip it over and multiply. I like to sort of visualize it as canceling, right? So if I'm trying to figure out what to multiply to get rid of the 1/2, I want to multiply by something that cancels everything out. And of course, canceling ones doesn't do anything. But since I multiplied by 2 over 1 there, I need to multiply by 2 over 1 here. 14 over 1 is, of course, 14. That's it. That's not the prettiest 2. This is a 2, believe me. Right, so this gives me 28 over 1, or 28. Which makes perfect sense, right? If half of x is 14, then x itself must be 28. So let me rewrite that in a little neater fashion. And again, my answer looks like x equals a number, which is great. That's what I'm going for. Okay, so that's a relatively simple operation still. Now, what happens if you have more than one x or more than one instance of the variable showing up, right? So let's say I have 2t plus 5 equals 3t minus 7. Well, then the thing the thing that you want to do is make it so that you only have one variable, right? We can't solve for t if there are 2 t's. So we have to get it down to just one t. So that's what we're going to do first. We're going to rearrange the problem so that we have all the variables on one side and all the constants on the other side. So there's a couple ways to do that. I think most people probably feel most comfortable putting all the variables on the left and the numbers on the right, and that's fine. You can totally do that. You can also put all the variables on the right and the numbers on the left, and nothing changes really. Like it's still pretty much the same thing. I'll go ahead and put all the variables on the left. Now I'll come back in a second and show you why you might want to do it the other way in this case. So what I'm going to do is I'm going to subtract 3t. I've got like terms here, right? These both have t's in them and no other powers. So 2t minus 3t is minus 1t plus 5 equals, well, 3t and minus 3t just cancel out. That leaves me negative 7. And we're basically back in the same situation we were in before, right? Where we have a simple expression on the left and a number on the right. And I'm going to keep going just like we did before. So I'm going to get rid of the addition in this case by subtracting 5. Negative t equals negative 12. And if negative t is negative 12, then t itself must be 12. Now you can also think of this last step as multiplying both sides by -1, and that's totally fine if you want to do it, if you want to think of it that way. I prefer to think of it logically, right? If negative t is negative 12, then positive t must be positive 12. Now, a quick check on this. If we want to, we can take this and put it back into the original equation, right? Just to see if we've done it right. And if we've done it right, then both sides should have the same value, because that's the original claim, right? Is that 2t plus 5 equals 3t minus 7. So if I plug in the value I got for t, that should be the case, right? The thing on the left should equal the thing on the right. So if I do that, I end up with 2 times 12 plus 5 and 3 times 12 minus 7. And so this is 24 plus 5 is 29. And here we got 36 minus 7, which is 29. Equal. So we're feeling good. Great. Now, let me tell you how I would actually do this problem if I was doing it for me. I would put all the variables on the right in this case, because 3t minus 2t is positive t. It saves this last step. And I like leaving things positive if I can. It tends to make the math a little bit easier. So I will usually, now I feel totally comfortable doing that. Whether you do or not, it's up to you. This worked fine, obviously. I would probably do minus 2t first and then plus 7 for my second step, and end up with just 12 equals t. But either way is okay. So when you have multiple instances of the variable, the first thing to do is get them all together in one instance of the variable. Otherwise, you have two things that you're trying to solve for, and you can't do both at the same time. So you want to get it all down to one so that there's just the one thing to solve for. Okay. Let's talk about the thing that usually ends up messing people up on solving linear equations, which is when they get messy, right? So let's say I have 4 minus 2 times 1/2 x minus 3 equals x plus 1. What to do now? All right, well, I'm going to do exactly the same thing, well, very similar to the same thing that we were doing before. I'm going to, number one, try to get the x's together, and then two, peel off all the things that aren't x. So the way to do that is, in this case, I want to use the distributive property first. So here, I want to simplify and then solve, right? Because this is messy, right? This is not a thing that I can deal with easily. So I have to simplify first, which means we're doing PEMDAS. So since I have to simplify the left side first so that it doesn't have those parentheses and it doesn't have the multiplication outside, what I'm going to do is PEMDAS, right? I'm going to simplify what's inside the parentheses, and then do any exponents, then do any multiplying, and then multiplying and dividing, and then do any addition, adding and subtracting. So simplifying the stuff inside the parentheses, those are not like terms, right? This has an x, this doesn't have an x, they don't combine. So there's nothing I can do there. There's no exponents anywhere here. Multiplication. So things I can multiply. Well, I have to multiply this -2 into here, right? It says -2 times this whole quantity. So I'm going to multiply the -2 in. So we're going to leave the 4 alone. And then when I do -2 times 1/2 x, well, -2 times 1/2 is -1. So I have minus x. And -2 times -3 is +6. This is looking more like something I can deal with, right? So now I'm combining the 4 and the 6 on the left side. 4 plus 6 is 10. And it's one common mistake is to think that this minus sign goes with this 4. It does not. This minus sign goes with the x, right? This minus sign is telling me that the x is negative, not the 4. This is a positive 4. Right, so this is +4 plus 6 minus x. So this over here is 10 minus x. And then we're in the same situation as last time. So I'm going to do what I would do for myself, which is move the x's to the right, just to keep it positive. So add x to both sides. 10 is 2x plus 1. Subtract 1. 9 is 2x. And so I have 9 equals 2x. Well, the opposite of multiplying by 2 is dividing by 2. 9 over 2 equals x. There you go. So sometimes the thing to do is to simplify until you're in a situation that looks sort of like this, right? Where there's no more parentheses and the exponents, if there are any, are gone. There won't be any exponents in linear equations. That's like the definition of linear, is that there aren't any exponents, at least on the variables. Yeah, so the thing to do is simplify until you get a nice simple situation, and then solve it. Okay, let me go on to something that maybe messes people up even more, which is, what if there are fractions everywhere? Not exactly everywhere, but we're going to put in some fractions and make things look a little different. 2x minus 1 over 3 equals 5x. Oh, excuse me, I'm going to do this a little bit differently. Let's do this plus, we'll make it messier, 5x plus 7 over 6, let's say, equals 5/12. There. This thing is going to be messy, and it's probably not going to come out very nicely. I haven't pre-made this up. So let's see how this goes. Okay. So the thing that's making stuff hard here is obviously the fractions, right? The over 3, over 6, over 12. That's making this significantly harder. So what you want to do is find your least common denominator of everything here, of 3, 6, and 12, which is to say, I need some number that 3, 6, and 12 all go into evenly. And I can use any of them, right? If I wanted to, I can multiply 3 times 6 times 12, and that would get me a common denominator, but not the smallest one, which is what I want because that'll be the least work. The smallest number that 3, 6, and 12 all go into is 12, right? If I just start counting by 3s, 3, 6, 9, 12, 15, etc., right? There's a 12 in that list. Same thing if I count by 6s, 6, 12, 18, there's a 12 in that list. And then obviously 12 goes into 12 one time. The reason I want this is that if I multiply both sides of the equation by it, it'll get rid of all my fractions. And that makes things as easy as possible, right? So what I want to do, since my LCD is 12, is this. Now, you can think of this as 12 over 1 if you want to. I guess I will. On the left side, let me point out that every one of these, we have to use the distributive property, right? So this 12 goes to this and also to this. So both of them get their own fresh copy of 12, right? When the 12 and the 3 cancel, that 4 that I'm left with is not what I'm multiplying here. I'm multiplying by another 12 over here. So let's do that. So if I do 2x minus 1 over 3 times 12 over 1 plus 12 over 1 times 5x plus 7 over 6 equals 5 over 12 times 12 over 1. Now, if I found my LCD correctly, what will end up happening is all the fractions will go away. So before I do any multiplying, I'm going to do this. And that makes things a lot easier because now there's no more fractions. Right now I've got 4 times 2x minus 1 plus 2 times 5x plus 7 equals just 5. And then from here, it's just a matter of simplifying and solving. So that's what I'm going to do, right? I'm going to distribute this 4 to the 2x and the negative 1. And I'm going to distribute the 2 to the 5x and the 7. And I'm going to block myself off a little bit of room. And then I'm going to combine all the things that are alike on the left side of this equation. 8x and 10x is 18x. Negative 4 and plus 14 is plus 10. Notice that I can't combine like the 8x and the negative 4. That doesn't work because this guy has x's and this guy doesn't. This is just numbers. This is something with variables, and those don't go together. So I can't combine them. So 8x plus 10x is 18x. Negative 4 plus 14 is plus 10 equals 5. And this is easy from here, right? Subtract 10 from both sides. 18x equals negative 5. And then divide by 18. So I end up with x equals negative 5 over 18. I guess I'll put that here rather than starting a new page. There you go. So let me recap. First thing to do, get rid of the fractions. If you've got fractions, it's probably best to get rid of them. You can certainly do the operations with fractions, right? We learned how to do, or you guys know how to do operations with fractions, and you can do things with them. And it works totally fine if you do. It's a little bit of a mess, but it does work. So for instance, like I could have said this fraction and this fraction have a denominator of 3 and 6. So I want them to both be 6. So I'm going to multiply this one by 2 over 2, distribute the top, etc. You can do that. It's probably not the easiest way. Probably the easiest way is the thing I did here. And then once we get to here, notice I've got 2 x's, so I combine them. Right, I got 8x and 10x, and that's 18x. And then I go about peeling off all of the things that aren't x. Right, I've got this extra 10 here, and the extra 18 that are schmutzing up my x essentially. And so I peel them off one at a time in the opposite order of PEMDAS. Right, so we're doing SADMEP because we are solving. Right, PEMDAS is for simplifying, SADMEP is for solving. And once you do that, you end up with this. Now, you can put that as a decimal if you want to, but I don't, right? I would much rather just divide by 18 here and be done. And I think most math teachers would agree with me that fractions are great for this, right? You don't have to go any farther. I don't have to do 5 divided by 18 and find out that it's like a little bit smaller than a third. I don't care, right? The thing I care about is just what does x equal, and however you represent it is up to you. So that's your basic equation with a bunch of fractions to cancel first. Now you can certainly have a different looking set of equations with fractions in them and cancel them. So here I've got a 2 and a 3 that I need to get rid of. And so my least common denominator for those is 6, right? Smallest number that they both go into. And so that's what I'm going to multiply both sides by, right? So LCD equals 6, LCD equals 6. And so that's what I multiply both sides by. And as before, when you are multiplying something that has more than one term in it, you need to make sure that every term gets a fresh copy of whatever you're multiplying by. So this is really 6 times half x minus 6 times 1 equals 6 times 2/3 x plus 6 times 3. 6 times a half, the easiest way to think of that is half of 6 is 3. You can certainly do this, right? If you prefer. I prefer to think of it as half of 6. 2/3 of 6 is 4. And then we're back in the same old situation as before. I'm going to go ahead and move the x's to the right because, again, the bigger one is on the right. So if I subtract 3x, it'll still be positive, or the x's will still be positive. And I subtract the 18 on both sides. So I end up with x equals -24. By the way, in case it wasn't clear, -24 equals x and x equals -24 are exactly the same statement. They mean completely the same thing. The fact that it's written in a different order does not matter at all. It'll matter when we get to inequalities, so watch out for that. But for equal signs work the same in both directions, right? The equal sign means these two things on opposite sides of me are the same. It still means that over here. Okay, so I think I probably want to wrap up there. Now, I guess there's two more things I want to show you. This is the basic idea about how to go about solving a linear equation. Is you're trying to isolate your variable. Like you'll hear that phrase if you read a book on algebra, you'll see the phrase isolate the variable a lot, and people often don't know what that means. What it means is get the variable alone, and then all the numbers left over on the other side are what it equals. So we're trying to get the variable alone by doing this stuff. And this stuff that we're going to do is peel off all the things that aren't the variable, right? So if I have an onion and I'm trying to get to the middle of the onion, I don't like try to push my way through all the stuff, all the layers of the onion. What I do is I peel off a layer of the onion, right? Peel off a layer, then I peel off another layer and peel off another layer, and eventually you're left with just the inside. And that's the basic strategy here, is peel things off one at a time until you're left with just the thing you want. Now, there are two other kinds of equations that we haven't talked about yet, which are identities and contradictions. So identities are always true. Regardless of the variable. The simplest kind of identity is something like this, right? That's true. It just is. It's just always true. So it's an identity. Another thing that's always true is that x equals x, right? Or 0 equals 0. These are really common final results that tell you have an identity. So if I have something like, let's do this, 2 times 3x minus 1. When we get the other side here, 6x minus 11 minus 9, right? So let's say I have this equation here. It doesn't look the same on both sides, so it's not completely obvious that it's an identity. However, when we go about simplifying, the thing I end up with is this. I distribute the 2 and I get 6x minus 2 minus 9 equals 6x minus 11, and then I combine the like terms. 6x minus 11 equals 6x minus 11. Now, no matter what x is, that's always true, right? If x is 1, the thing I get is -5 on the left and -5 on the right, obviously, because they're the same expression. And so that's what an identity is. An identity is just something that is always true regardless of the value of the variable. And the way you can identify them is that you'll eventually get to the point where you have the same thing on both sides of the equation. And that's it, right? That's when you get here, you are done. There's no more solving to do, right? Anything else you do from here is just going to be getting you closer to this 0 equals 0, right? I add 11 to both sides and I get 6x equals 6x. Subtract 6x from both sides and I get 0 equals 0, right? So identities are sort of always headed for 0 equals 0, but as soon as you identify that you have the same thing on both sides, you're done. right? It's an identity and there's no more solving to do because it's always true. Contradictions are never true. So for instance, let's use a very similar looking one. 2 times 3x minus 1 minus 9 equals 6x plus 3. Right, so very similar to the last one. So let's see what we get. Distribute the 2 like before. 6x minus 2 minus 9 equals 6x plus 3. Combine. 6x minus 11 equals 6x plus 3. And now you might notice that when we get rid of the x's, right? So that's what I've been doing in the past. When I get down to here, I want to get down to just one x. I will subtract 6x from both sides. When I do, the thing I'm left with is this. A statement that negative 11 equals 3, which it does not. It's always false. So this is never true, and therefore this is never true, because this is like this and this are equivalent to each other, right? All I did was simplify. I didn't do anything funny here. I just simplified this this expression to end, and then started solving it to end up here. I didn't change anything about the value. I just changed the way it looked. So what I have is negative 11 equals 3, which is always false. And so this is a contradiction. And so there are no solutions to this equation. So what I get is no solution. Right, that's my answer. There is no solution to this equation because it is a contradiction, right? That it cannot both be true, that 2 times 3x minus 1 minus 9, or it cannot be the case that this side of the equation and this side of the equation have the same value. It's literally impossible. Put in anything you want for x, you will always get different values on the left and right. There's no way to make this happen, or no way to make these equal. And one of the ways you can identify that is that you have the same coefficient on your variable, right? So that's a thing that should make you very suspicious. If this 6x over here and this is 6x over here, that's a good heads up that maybe you've got either an identity or a contradiction. The contradiction comes up like 6x minus 11 and 6x plus 3 cannot both be the same, because the 6x's are the same on both sides and they cancel out, but the other stuff isn't the same. Same thing over here, right? The 6x's are the same on both sides and they cancel out, and then the other stuff is the same, right? So this is always true no matter what x is, and this is always false no matter what x is. And you can get into one of these two situations if you have the same coefficient on the variable on both sides. And if the variables all get canceled out, then you get something like this. That's kind of all I want to say about solving linear equations. When you're solving linear equations, the basic overall strategy is to combine all copies of the variable into one copy, and then peel off all of the stuff that's not the variable. That's the basic idea. Sometimes the combining can get a little messy, right? Where it's really helpful to get rid of all the fractions using the least common denominator, right? So always be on the lookout for the opportunity to get rid of fractions. And this is how. Find your least common denominator and multiply everything by it. Same thing here, right? Getting rid of fractions is great. And then once you do that, combine all your x's together, put all your numbers on the other side, peel things off one at a time in the order of SADMEP. And you stop when you get x equals some number, or t equals some number, or whatever variable you're using equals a number. If you encounter one of these weird situations where all the x's are gone, then that means that you've got either an identity or a contradiction. right? If all the x's go away, you actually can't have something like this. This, by the way, is called a conditional equation because it'll be true depending on what x is, right? There are some values of x for which it is true and others for which it is false. In fact, there's only one value of x for which it's true. X equals -24 is the only thing that makes this true, and if x is anything else, it's false. So it is true conditional on x being -24. This is not conditionally true. It's just always true, regardless of what x is. This is not conditional either. It's just always false, no matter what x is. So if you get just a single answer, it's a conditional equation. Whereas if you get everything's an answer or nothing's an answer, then you've got an identity or a contradiction. So that's your basic idea. Simplify everything. Get rid of all the fractions first, get all the x's together, get all the numbers on the other side. And then peel things off that aren't x until you are left with just one number on your right side and x on your left side. That's it. That's your basic solving linear equations. All right, I think I want to go ahead and stop there. There's a lot of stuff you can say about solving linear equations, and there's a lot of sort of twists and turns you can put in. You can make them harder by throwing negatives everywhere and tons of fractions and all that stuff. But that's not what I want you to concentrate on here. What I really want you to concentrate on is just the basics. Make it look relatively simple. Peel off all the stuff that's not your variable, and that's it. That's pretty much it. And the way you do the peeling is by using the opposite operation of whatever thing you're trying to get rid of, right? You're trying to get rid of addition, you use subtraction. Trying to get rid of division, you use multiplication, etc. And once you're down to just x equals something, then you're done. The way you can check your answer, and by the way, on a test, for instance, you absolutely should check your answers, is you plug it back into the original. And it's important to use the original equation, not something along the way, because if you made an error before you plug in, then you'll get the wrong thing at the end. Like it'll come out being equal when it's boy, I'm not saying this very well. It'll come out looking like it's equal when it's not actually, if you plug in after you had already made an error. So yeah, that's I think that's where I want to go ahead and stop this and let you practice a little bit, and we'll talk more about what you want to do with linear equations in a little bit. But I'll go ahead and stop there, and I will see you guys in the next video.